Howdy, Algebra 2 students. It's Mr. Naughton. We are going to do some piecewise functions today. We're going to spend 2 videos on piecewise functions. Today, we're going to go ahead and call it restricted domains because we are going to be looking at one function, but rather than the whole thing, we're going to be looking at just a piece of it. So let's first talk about a piecewise function in general. It's a function built from the pieces of different functions. So as we can see here on our graph, we have a blue function, a red function, and then a green function. So the idea is that it's not the exact same graph the entire time. The way I like to explain this is think about when you're having a shop and say your business is ice cream. Okay, if we were to just go ahead and draw a graph and say what we want to know is we want to say what is our profits for ice cream based on the time of year it is. Okay, so obviously in the winter, if we start here in January, our profits are going to be kind of low. We're not going to make very much. And then as they get bigger, say we get to March, well, things are going to pick up because it's not winter anymore. Things are going to be like, okay, we're making money. And then, of course, in the summertime, we're like, whoa, making so much money. Okay? And then when it comes down to fall again, it slows back down. Cool? And so that is a good example of a piecewise function. So again, beginning of the year, we're not selling a whole lot of ice cream because it's cold out. Then it gets a little bit warmer. We're making more money. And then again in the summer, so much money, life is good, and then tail off again. Okay? So we can't say what is that function because they're made up of different pieces. So we call that a piecewise function, okay? So that's a good example. Couple of things you need to know. A closed dot means it includes that value. So you can see we have closed dots here and here. So that means we include that one. Open dot means we do not include that value. So it basically goes to right before that value. And then once it gets to 2 or once it gets to 1, it stops. And then restricted domains is what we're looking at. So we're looking at specific intervals or terms. So let's start with evaluating. When we evaluate, that means our answer is a number. So just straight off the bat. So what we're saying is we have a function like our ice cream store where it does stuff when it's less than 2. So I'm just going to say less than 2 because that's what that means. And then this was going to be like in between. So I'm going to write that there. And then on here, we have another function when it's greater than. So the idea is we are going to go ahead and look at saying, what are the values? If we have a value that is less than -2, it's going to go in this function right here. If we have a number that we're going to plug in that is in between -2 and 1, we're going to plug it in there. And if it's greater than 1, we're going to plug it in that bottom function right there. So let's take a look at our first value. Again, the idea is you want to plug it in. So I'm going to plug in 0. But where? Into which function should we plug it into? So let's ask ourselves, with that number 0, is that less than 2? Nope, not less than 2. Is that greater than 1? Nope, it's not greater than 1. It is, yay, in between -2 and 1. So that function, x plus 1, we're going to take that 0 and plug it in for x. So 0 plus 1 is going to be 1. So our final answer on number 1 is 1. That's always fun when that happens. All right, so let's look at number 2. I'm going to erase my smiley faces and my x's because I have a different one. So I'm going to be plugging in the number -8. So where does -8? Is that greater than 1? Nope. Is that in between -2 and 1? Nope. Is that value less than -2? Yay, it is. So I'm going to take that -3/2 x minus 1, and I'm going to plug that -8 right on in there. So -3 times 2 times a -8 minus 1. Now, I have a fraction, obviously, right here, times a non-fraction. So to make it easier, I'm going to make that -8 over 1 a fraction to make multiplying easier. So now I'm just going to multiply across here And I'm going to get 24 over 2, which is going to be 12. So I'm going to have 12 minus 1 because of our minus 1 right there. So my answer there is going to be 11. Woohoo! Alrighty. Once again, I'm going to erase my smiley faces for our last example here. I'm going to say f equals negative 2. So remember when we say f of x, right? And we say that's the same thing as y, right? So we're going to say, hey, x is negative 2. So, okay. So really this is just saying, hey, when is x negative 2? Whoa, this is going to be a little tricky. Because check this out, sports fans. I have negative 2 in 2 spots. So which one does it matter? Well, let's look at our inequality. So in this one, it is less than. Boom. This is less than or equal to. So in this case, this one is going to go into where it's less than or equal to because it is equal to that value. So this is going to go into the x plus 1 function. So we are going to have negative 2 plus 1, which is going to be a negative 1. And that is our answer. So again, when it says evaluate, notice our answers are always numbers. Good to know there. If it says evaluate and you didn't get a number, something went wrong. Either a bad example or we goofed in some way. Cool? So the next part we're going to do is obviously graphing. Okay, we have graphs on there. So let's do a little review for graphing before we jump into it. So remember, when we graph, we use the for y equals mx plus b, where m is our slope, and then our b is our y-intercept. If you need to go ahead and review this a lot more, go back to day 2. We talked a lot about this, but again, we're doing the crash course. So with our slope, if it's positive, it goes up, and negative, it goes down. And remember, we always go to the right. You good with that? And then our y-intercept is obviously going to be our y-axis. We called it begin and we called it move. Alrighty. So with that being said, let's go ahead. I'm going to erase this so we can focus specifically on the example at hand. So what we're saying with a piecewise function, and this is why this is an introduction into piecewise, is I don't want to have multiple graphs. I want one graph. Okay? So this is really just one graph. But it is not the whole graph. It is what we're going to call a snapshot. Okay? Kind of like a picture in time. So I don't want the whole line. Okay? So not the whole line. Cool? So we're going to go y is equal to mx plus b. Remember in our video we crossed out the y's and the x's. So m is 2. Which is the same thing as saying 2 over 1. And our b here is negative 1. So we started here. Now, before we get going, I would recommend doing this part in pencil, okay? And then having a pen nearby, or else you're going to be doing a lot of erasing and scribbling and it's going to get confusing. Or just put your pencil down and watch this example, then hit pause and fill it all in. So I'm going to start here at negative 1. Notice my slope is a positive 2, so I'm going to go up 2 over 1 big dot, up 2 over 1. And then I'm going to fill the entire screen because that's what we're supposed to do when it's y equals mx plus b. You good with that? So this is how it would look. But because it's a piecewise function or a restricted domain function, we only want part of it. Again, so we only want part of the line. So which part do we look at? That part is this right here. It is saying less than or equal to 1. Okay, 1 where? So it's 1 on the x. So where does 1 hit x? So this is 1 on your x-axis. And I want less than. Well, a little hint is that arrow, my inequality arrow, points to the left. So we're going to say left of 1. So if I were to mosey on down here, I'm going to go ahead and do 1, and then I'm just going to fill in the left-hand side like that. And because it's or equal to, just like we talked about, that's going to be a closed dot. If it was not or equal to, it would be an open dot. So, this is why I said this too, and with pencil, all these other dotted lines or dots you want to erase so we can see just that part. Cool? So again, this is specifically your answer right here. Okay, not the whole line, just part of it. Gravy? Let's do that one more time so we can see this. All right. So I'm going to go y is equal to mx plus b. Cross out my x's. My m is a negative 3 over 2, which means that this is going to go down as we go from left to right. And my b is a negative 1. That's fun. That was negative 1 in both examples. So start here at negative 1, down 3 over 2, down 3 over 2, down 3 over 2, and then the same backwards. Because we want to fill up the entire screen. And then we'll do some erasing. So I don't want the whole line. That's why I only did the dots here, and I didn't fill out anything until I look at my restricted domain. So this is saying greater than 2. So it's definitely going to be an open circle. Got a bell. Hold on. Means I need to wrap up this video quick. So we're going to go ahead and say, hey, it's greater than negative 2. You with me? So where is x equals negative 2? That's right here. So I'm going to go down to where I meet that actual point, put an open circle, and then it's pointing to the right because it's greater than. So I'm going to go to the right. Boom. Erase this. Cool? Alrighty, that bell rang, which means I got to skedaddles. You guys have a wonderful day. Do your assignment /homework/home fun, and we'll see you next time.